Hi everyone, and welcome to today's Red Hat webinar. Before we get started with today's presentation, there are a few items to quickly mention. You should see a taskbar at the bottom of the screen. Each icon is assigned to a particular element of today's webinar. If you're not sure what the icon does, hover over the icon with your mouse and the box will appear to tell you the function. Also, next to the slides window, you should see a blank Ask a Question box that allows you to type a question. After you type the question, click Submit to send it to our presenters. Feel free to submit your questions throughout the webinar, and our presenters will address as many as possible following the presentation. You can submit any technical questions related to the webinar platform here. Please close down other browser windows or applications that might be splitting your bandwidth, including VPNs, as these might interfere with the audio or video stream. If you experience any connectivity issues, please refresh your browser. Today's session is being recorded, and all registrants will receive an email within 1 to 2 days of the event with a link to view this presentation on demand. Now I'm going to hand it over to today's first speaker so we can get started with the presentation.
Mark Thacker, Security Experience and Principal Technology Product Manager and Team Lead in the RHEL team. Mark has over 28 years in the IT world, helping customers understand security capabilities of their operating systems. Without any further delay, Mark, please take it away.
Great. Thank you, Daniel. Appreciate it. I just wanted to let everyone know that we will be definitely doing Q&A at the end of the discussions today. So if you have any, please do feel free to submit them through that Q&A chat window over on the left-hand side. But with that, we're going to go ahead and get started. So again, as Daniel said, my name is Mark Thacker. I'm a product manager in the Red Hat Enterprise Linux team. And I primarily concentrate on security technologies, specifically those related to Red Hat Enterprise Linux. So we're going to talk about vulnerabilities, risk management, and patching. Now, I could have entitled this CVEs and everything you want to know about CVEs, but it's a little more complicated than that, as you know in real life. So let's just dive right in. So we're going to be talking about what security vulnerability is, how patches are created, how security vulnerabilities are scored, why sometimes the scores that you see from something such as the National Vulnerability Database and those supplied by Red Hat are different from each other, and what we're doing to address that difference. How Red Hat chooses to address CVEs and how we release that to the world. And I'm also going to give you some pointers to our Product Security Center, which is where you can get a lot of hands-on tools, access to data sources, and access to our CVE data feed. So again, feel free to ask your questions as we go along. They'll queue up at the end, and Daniel and I will then switch into an open Q&A mode. First things first, what's a vulnerability? It's important to remember that when we talk about patching and security patching, we have to understand what a vulnerability is. It sounds like it's a pretty obvious statement, but you have to remember exactly what it is, right? That we're talking about a software, hardware, or firmware flaw. In recent years, we've seen that security vulnerabilities are not limited to just software. As you know, through Spectre and Meltdown, there are sometimes fundamental hardware design issues that are security vulnerabilities. It's important also to remember that different types of attacks can occur, and the complexity of the attack, as well as the system that is under attack, determines your risk, right? So we have seen situations where there are potentially security vulnerabilities that could expose very sensitive information. However, that information is very difficult to get to, or the attack vector is shockingly complex. And that absolutely influences your response as a customer to addressing those issues, Red Hat and any other vendor's response in terms of how we actually address and generate patches for those issues as well. Quite frankly, over the last few years, we've even seen certain types of CVEs that the only true mitigation is to replace the actual underlying hardware device that may have a flaw in it. There may be mitigations and ways of working around it, but sometimes it's very dependent on the exact deployment scenario in which that vulnerability is exposed. CVEs, common vulnerabilities and exposures. This is the common nomenclature used to describe a particular security vulnerability. One thing to remember is that a CVE identifies a unique vulnerability, not necessarily a unique product, but definitely a unique vulnerability. For example, if there is a flaw in an implementation of, say, the TLS protocol in OpenSSL, that particular flaw will have its own unique assigned CVE number. Red Hat is actually an authority in the ability to generate CVE numbers for our own products, and there are several organizations around the world that have the right to generate CVE numbers. And so you'll see whenever you look at perhaps the Red Hat CVE database, you'll see these CVE numbers, and they all follow a standard format. The phrase CVE followed by a year and a individual unique number. And that is how you identify a unique CVE. I'm going to pause for just a moment, and I want to make sure that the audio is working. Can everybody hear me well enough? Okay. All right, let's go ahead and move through then. All right, perfect. Thank you for those immediate responses. I appreciate that. So Red Hat actually maintains a CVE database. The CVE database is readily accessible. You can see the URL right here on the screen. It does not require that you actually have a Red Hat subscription in order to access our CVE database. We like to make this information very public. Also, remember when you look at CVE numbers, I've had this question before. Sometimes CVE numbers, you may make an assumption about a CVE number based on the date that's in that CVE number, but you don't really need to do that. They are assigned sometimes way early in the discovery process before that CVE is made public, right? Or they could even be retroactively assigned based on perhaps discovery of an existing issue or rediscovery that an old issue still has a persistent problem. So just know that the CVE number is unique. That's the most important. So the CVE number is essentially a serial number describing a very unique vulnerability. Who responds to CVEs here at Red Hat? We have an entire dedicated team. It's the Red Hat Product Security Team. The Product Security Team focuses on responding to requests about CVEs. It focuses on working with our upstream community to understand what CVEs are in upstream products. It also acts as a liaison point between Red Hat and other products teams around the world, and other product security incident response teams, PCERTs, for example. So we work directly with hardware vendors, other software vendors, our competitors, with everybody in the IT world that's focused around security. We are part of that cabal of security vendors that are informed, know what's going on, trusted with embargoed material before CVEs are released. And we start to work on security vulnerabilities and how to address them, obviously, as soon as we find out about a vulnerability. And we also work with other vendors to ensure that there's a consistent response about how to address industry-wide problems with vulnerabilities as well. So again, the primary focus point is our product security team. Now at the end of the deck, I give you a few URLs that will refer you to the product security team's web pages, but they're all basically off of the access.redhat.com website. And there is the ability for you to send an email directly to the product security team. There's an email, it's listed at the end, but it's SecAlert, SecAlert at redhat.com. SecAlert goes directly to the product security team. If you feel that you have discovered a unique and new vulnerability in any of Red Hat's products, do not hesitate to reach out to SecAlert. Even if you're not a Red Hat customer, you certainly can do that. But as Red Hat customers, of course you can do that. You can work through your account management team as well if you have questions about what you think might be a security flaw or vulnerability, and we certainly will involve the product security team. That brings up the question, let's say that there is a problem, right? How does this flow go from undiscovered problem to patch. So we created this little graphic. It's actually a little more interesting when you see the animation, but for these purposes, I didn't want to do animation. But over on the left, let's start over there. Essentially, someone's going to discover a flaw. That's potentially an evil hacker. That's bad. We don't want them to be the first one to discover it. It could be Red Hat engineering. We obviously do proactive tests. We do scanning. We do vulnerability scan. We do code analysis of our code as well. It's very often a security researcher. It could even be a different security vendor. That's how most of the big name vulnerabilities are discovered, is independent security researchers. Could be you, could be a customer. Regardless of the source, eventually the Red Hat product security team gets involved in the discussion. Take, for example, if it was a security researcher, often that researcher will reach out to affected vendors. All of us will come together. The product security team's equivalent of all the various vendors will come together to discuss, often with that security researcher, the details of the flaw. And we then involve our PCERT analysis team, which is, again, is the product security incident response team. These are experts that analyze how that flaw affects Red Hat products. If you take one thing away from today's conversation, it should be that when it comes to understanding vulnerabilities on Red Hat products, we have a team that's dedicated to doing that. We cannot and do not just simply accept an outside firm's opinion about what a potential vulnerability's impact is on a Red Hat product, because only Red Hat truly understands how we built our code, how we built our products, what compiler flags we used, what our default values are when we build our technology. Sometimes we have to work with our upstream partners and our upstream communities to influence how a fix can roll out. A good example of that is the Spectre and Meltdown vulnerabilities. Those required a fundamental change to the way that the Linux kernel does scheduling and how it responds to various flushing commands. So that was upstream work that we and others helped coordinate. When the patch is ready to be announced, or rather when the vulnerability is ready to be announced, Red Hat has an entire process dedicated to staging and pre-building our patches before public announcement. That's ideal. We really do want to do that if we can, right? Is to make sure our patches are available before public announcement. Of course, when it's announced, then we make the patches available across all of the deployed platforms, including our container technologies, which are often respun on demand based on critical or important CVEs that get released by Red Hat. We'll talk about what critical and important means in just a moment. When you talk about CVEs, you or your vendor of choice for security scanning will often refer to what's known as a CVSS, Common Vulnerability Scoring System. There's multiple versions of a CVSS scoring system. The most common one today is version 3. That's what you actually see here on the screen. And this really long, obnoxious string actually fully describes a given CVE's CVSS score. There are components of this CVSS score. And the reason why it's important to understand this is it answers the question about, well, why are scores sometimes different from each other, right? So just looking left to right, you can see that this is a string that describes a score for a particular CVE. This was done with Common Vulnerability Scoring System version 3, that the combined score is a 9.8. Pretty high, right? There is an upper limit on this. But you'll see that there are factors in here such as the attack vector, right? This one comes across the network. The attack complexity, is it hard or easy to potentially exploit? This one looks like it's an easy to exploit one, low attack complexity. Do you require privileges? Right? This one says, no, I don't require privileges. If you require privileges, by the way, obviously that makes the vulnerability a little harder because you have to already have obtained privileges. User interaction, is there anything the user needs to do for this exploit to occur? The scope, right? So does it cause a elevation of privileges of the process that's being attacked? And then the CIA triad, the confidentiality, integrity, and availability of the system, are those in any way compromised or likely to be compromised if the CVE is exploited? So there you go. You are all now CVSS scoring experts. which will absolutely lead us to the next point of conversation. What about risk? When I talk to customers, I often get queries around CVE policies that U.S. customers have, which are based around CVSS scores. If you're in the financial sector, your most common reference point is the PCI DSS standard, the Payment Card Industry Data Security Standard. PCI DSS has, throughout its many versions, criteria laid out that says you as a bank, you as a financial institution, have to respond and patch any CVE with a high CVSS score. The actual number has varied over time, but it's really, really, really important to understand that CVSS scores do not equate to risk. They are a factor in risk. So I said, if there's one thing you have to remember, this is the other thing to remember. A CVSS score that looks high, right, in some database, that doesn't necessarily tell you everything you need to know about risk, right? So when Red Hat learns about a vulnerability, we actually generate our own score for that vulnerability. Why do we do that? Because we look at how does that flaw, how could it be exploited in a Red Hat product? For example, if it's a stack smashing flaw, it's going to score really low because all of Red Hat Enterprise Linux, as an example, is built to prevent stack smashing, right? So by default, it's just not going to be an exploitable issue. If it's a a container flaw, then we have to look at the fact that we have tools such as SE Linux enabled by default in all of our platforms that prevents most container CVEs from escaping. And in fact, to date, SE Linux has actually completely prevented all of the current known container vulnerability issues. When we're looking at risk, we and you have to evaluate if we were to produce a patch, would that patch actually break compatibility, right? So I'll let you in on a secret. The way that the upstream world generally deals with CVEs is a new version of a library, a new version of utility is generated. That's great in isolation, but you don't run that utility or that application or that library in isolation. You're running it on a production class system with a lot of dependencies. So when Red Hat evaluates a CVE, we definitely will set a score for that CVE, but we also work with you to communicate what the possible impact is on addressing that CVE, right? So for example, a low-scored CVE might be possible to address, but in so doing, we might actually break our ABI and API compatibility promise to you as customers. So patching a security problem may actually introduce a completely incompatible or unstable system. That's not good. That's not what you want. Are there mitigations built in? I mentioned SE Linux, stack smashing, etc. We know that. We actually track that. Even in RHEL 8, you can actually tell how each binary in RHEL 8 was built through a tool called AnnoBin and AnnoCheck that allows you to introspect the way that we built Red Hat Enterprise Linux so that you understand what security flags we used when we compiled Red Hat Enterprise Linux. But from your perspective, as a customer, when you look at a CVSS score, you also get to score it yourself in a way because you have to factor in your risk factors. Are the systems that are potentially affected part of a DMZ? Are they part of your production workflow? Are they performance sensitive, right? I'm fully aware of customers that have chosen to defer to implementing certain CVE fixes because they would have a performance impact. As a customer, you should expect Red Hat to work with you to understand what performance impacts there might be when you implement a security remediation. Spectrum and Meltdown are perfect examples. The first iteration of patches for those did have a pretty significant measurable performance impact. The second generation mostly eliminated that performance impact. So we had customers that consciously chose system availability, uptime, or performance over addressing a particular security CVE. This lends me to the next part of a conversation real quickly around our supply chain. So when Red Hat chooses to deliver open source technology, which everything we do starts in the open source first, we work in the communities, we lead those communities where possible, we bring in that technology through a Bugzilla package review process, which simply means we have to identify that this is code that we want to deliver, that it has a supported upstream, that we can agree to support it, that there's going to be the ability to do our own QE process on that code. We don't just ship whatever's latest in the open source world. We then release that technology in the case of RHEL, and this is mostly a RHEL-focused discussion. We release that technology first through our Fedora upstream distribution. Then from there, we will select a subset, right, of packages and technologies to bring in Red Hat Enterprise Linux. We then do additional static code analysis. We will do an analysis on the security architecture of the package as well. And we will also do, quite frankly, basic virus scanning, because you still have to do that. We compile the source again. We don't just take it straight from Fedora. We compile it according to our RHEL hardening standards. RHEL 8, for example, has several new compiler flags to prevent, or actually to provide user address space layout randomization and position independent execution. And to take advantage of hardware security technologies as well. We run everything through our own QE process. And of course, when we ship it, we sign the packages so you can authenticate that the package that's on your system is from Red Hat. We encrypt and securely deliver that package to you. And of course, the focus of most of this presentation is the continuous security updates. But it's just important to put this whole CVE, CVSS discussion in the context of how we manage our supply chain. Let's move to the middle part, which is talking about scores, right? In particular, and also talking about what Red Hat chooses to fix. In particular, there's something known as the National Vulnerability Database. This is primarily from MITRE and NIST. It is considered to be, by many customers, an authoritative source of scoring data. Well, it's important to understand the way that it has worked traditionally. Generally, when a CVE is created, and a CVE number is assigned, there is one person and one entity that gets to assign the score, the CVSS score. Remember, we talked about that long string that represents the CVSS score. In the past, it's mostly been the upstream or the source code maintainer, right? And for proprietary source products, it would be that proprietary vendor. In the case of open source products, it's typically the package maintainer in the open source upstream world. But that score does not take into account anything about the actual platforms upon which that technology is deployed. A good example, if you look at Firefox scores, right, for the Firefox web browser, the underlying assumption on any Firefox score is that the administrator is running the Firefox web browser. On Linux systems, you don't run as administrator, right? You don't log in as root and fire up Firefox and use it all the time. I'm not saying it's impossible, but that's not the norm. You're normally running as an unprivileged user, and thus when you look at a score for something like Firefox, as an example, that CVSS score has assumed worst case scenario with absolutely no knowledge about how the typical workload is used on a system, right? Now, in the past, I will take a slight exception. There's generally only one score that appears in the National Vulnerability Database. This has changed over time. What we are starting to see now, and this kind of mirrors what's going on in the right-hand Red Hat column over here, Red Hat is actively working with the National Vulnerability Database to make sure that our scores are listed if they are different from NVD, that the explanation for why we scored something different is clearly available in our Bugzilla report for that particular CVE. And in many cases, we have started working with NVD to make sure that they actually update their scores with new information. In many cases, we've seen scores come in. We've worked with NVD and said, look, actually on Linux systems in particular, this flaw is not as bad as what it looks like, or this flaw may actually be worse than what it looks like. Here's why. Not just for Red Hat, but generally. And NVD has updated their scores to reflect input from Red Hat and other vendors as well. So over on the right-hand column, Red Hat generates its own CVSS scores for CVEs, again, based on how we build our products, how our products are used, and those scores may change depending on the individual product under test, right? Individual versions of operating systems. RHEL 6 is going to get maybe a different score than a RHEL 8 system would because, again, they're actually built differently from each other. Okay? If you want to see and understand the differences, you can actually take a look at the MVD database, and you can actually see, for example, in this case, you see a CVSS score of 7.7 from Red Hat and an 8.6 from NVD. Why? When we analyze this particular CVE, you can tell that the attack complexity on a Red Hat system is very high. That means that this is much more difficult to exploit than what the originator of this score thought it would be. So in general, the upstream maintainer assumed that it was very easy to exploit this CVE, and it turns out on a Red Hat system, it's not so easy. So that's why we may change the score. Does not always mean that Red Hat lowers the score. I've heard that comment as well. No, sometimes we raise the score, right? Because it depends on how the attack complexity is. Also, it can depend on the analysis. We've sometimes find that the original analysis of the security flaw is not as thorough as it probably should be. When Red Hat lists CVEs on our website, we actually use a 4-point rating system. So rather than giving you just the CVSS score, we break it down into a little more easily to understand categories: critical, important, moderate, and low. And our SLA around what we build and what we fix is based around this particular scoring system. And so you can see it broken out here. Criticals are just like they sound. These are bad. You definitely want to address these as rapidly as possible. These are the ones that we tend to make available day zero whenever the public announcement goes out, right? These are really bad things. Easy to exploit, easy to elevate privileges, doesn't require any user interaction. Next is important. Importance are items that could still be very bad things, right? Allowing an unprived user to gain privileges, could still be remotely exploited, right? Could cause authentication issues, etc. Next to that is moderate. Moderates are more difficult to exploit. It typically requires an unusual use case to exploit or a very odd configuration. And then finally, we have low. Low are issues that, yes, they do represent a security flaw, but it might simply mean information that would otherwise be public is exposed anyway, or it does not result in a privilege escalation or breaking of your confidentiality, integrity triad. So those are our 4 scaling points: critical, important, moderate, and low. Which then brings us to the discussion of, so what does Red Hat fix? Our policy around CVEs was actually updated in October 1st of last year. And in fact, if you look on the URL down at the bottom, you'll see a little blog that I wrote that explains this a little bit. Essentially, starting October 1st, any CVEs that we have classified as critical or important, Red Hat is committed to providing a remediation for those critical and important CVEs across all active RHEL products, right? So that includes RHEL releases that are in our extended update stream support, any active products that still have an errata stream available to them, and for example, anything that's in, say, our SAP support policy as well, right? That's another ISV that has an extended support to it. What exactly gets fixed can be subject to our RHEL 6 and RHEL 7 extended update support package list. If it is a moderate or a low in particular, that can be part of the factor in factoring in what gets addressed. But for CVEs that are critical important, we will address those for sure. But again, sorry to clarify this, I just realized what I said sounded a little confusing. Critical and important, we will absolutely fix for all active releases. But if a product has moved into an extended update support release, then the policy is subject to an exclusions list, or what we call actually an inclusions list. It's called the package inclusions list. And that specifies which packages are actually subject to being fixed long-term in extended update support. Because remember, extended update support for a RHEL release is all about stability. It's not about fixing every possible security flaw. That's not stable. Witness the previous conversation around risk management. This is all about ensuring that you have a stable system. That's why we have a package inclusion list for RHEL 6 and RHEL 7. In RHEL 8, we have drastically changed and enhanced the way that we deal with extended update support. So in RHEL 8, we introduced this concept of an application stream. Each application stream consists of packages or modules. They have their own life cycle. And as long as that module is active and part of its life cycle, then we will address criticals and importance for those packages in RHEL 8. Okay, moderates and lows. So let's deal with moderates and lows. We talked about criticals and importance, moderates and lows. Moderates and lows, we absolutely certainly can fix them during a normal product update cycle. I have seen situations where a moderate will get an asynchronous release, right? A security update, if you will, depending on often the public nature. If this is a really public CVE, we may actually choose to release a moderate sort of out of sync. But generally, moderates and low are dealt with in the normal update cycle of the Red Hat Enterprise Linux product, which for RHEL 8, we have major releases every 3 years, minor releases every 6 months. And if you just saw today, on April 22nd, we announced Red Hat Enterprise Linux 8.2. And gee, imagine that. It comes a year after we announced 8.0, because every 6 months we're releasing a new release. And there are several moderate and low CVEs that were addressed in 8.2. Okay, so this is your one slide that tells you what Red Hat fixes. Now let's move into this next part. But before I do, I want to make sure that you saw this URL and this email address again. In particular, secalert@redhat.com. That is whom you reach out to via email if you have any questions about a security vulnerability, or in particular, if you are a researcher or you think you have found a problem, feel free to reach out to SecAlert, right? That's a ticketed system. It isn't just an alias. We actually generate a ticket that we have to respond to. As customers of Red Hat, you certainly can invoke your TAM or your customer representative to open up tickets as well if you have questions around patching a particular CVE, or as you see at the bottom, let's say that there is a low or moderate that for your use case, you feel like, you know what, I understand Red Hat Score, but I really do need this issue mitigated in some way. Open up a ticket. We are happy to have that conversation with you about why we rated it the way that we rated it if it wasn't clear in our notes. And in some situations, we may choose to respond to that with an individual security workaround or a patch, depending on the nature of the issue. Let's move into this last section. This is about identifying vulnerabilities, because often I find there's confusion around what's an authoritative source of a vulnerability and how do I do scanning. I just now touched upon the concept of the release cycle of RHEL. Well, it's also important to remember that CVEs and security fixes are backported, right? So I mentioned before that in the upstream world, the concept is we'll move to a newer version of a package, that newer version, everyone just is expected to move to that. Well, we don't do that with RHEL because we want to give you a stable operating system. So we as Red Hat will see fixes in the upstream, and then we'll bring those back to older versions of libraries and applications and even Linux kernels, right? So any given major release of Red Hat Enterprise Linux is on a particular major version of a Linux kernel. We're not going to update the kernel to a brand new version during the lifecycle of Red Hat Enterprise Linux. But we absolutely bring back security enhancements and security fixes from the upstream community into our supported products. So when you look at the Red Hat CVE pages, you can see exactly which products are affected. You can see the scores associated with it. You can see our 4-point rating system with it as well. Okay, so the key here is security fixes are backported. Now I will tell you, there are third-party vulnerability scanners that are not inherently aware of this. And they will do things like look at a version of, say, OpenSSL. And they look at the version based on the package number that they see in a Linux operating system, and they will say, oh, that version definitely has a flaw because in the NVD database, it says that version of OpenSSL has a flaw. That's kind of useless because with Red Hat, we backport, right? And we're not going to change the shipping version. We will do a little appendix. There's like an extra few digits that indicate that it's a newer version, but OpenSSL 1.1.1 is going to remain 1.1.1, but with enhancements over time. So if you just look at the version of a package, that will not fully inform you about what has been done. Instead, you need to look at a database that tells you which CVEs have been remediated in which releases of security advisories from Red Hat. And that's the kind of a screenshot that you see here on exactly how that works. We also make a freely available tool. It's known as OpenSCAP. SCAP stands for Security Content Automation Protocol. OpenSCAP has some primary functions in life. One, it is actually a security configuration scanning and remediation tool. So if you need to build a system and have that system be DISA-STIG compliant, PCI DSS, HIPAA, ACSC Essential 8, something like that, where it's a security configuration standard, that's exactly what OpenSCAP can do for you. We make freely available profiles that allow you to scan your system, assess your system against those profiles, and then generate either Bash or Ansible playbooks to bring your system into full compliance standards. Another aspect of OpenSCAP is the ability for you to consume Red Hat OVUL data feeds. And our OVUL data feed actually provides a listing of all the CVEs that we know of. It also lists which patch remediates those CVEs. And using OpenSCAP, you can scan your system and determine, oh yeah, I've got a potential issue here. I need to go get this new version of this patch and install it in my box. Well, what if you have more than one box, right? You don't want to do this manually. OpenSCAP is totally integrated with our Red Hat Satellite product for administrating this across your entire infrastructure, and also our Insights service as well. So, by the way, if you read the new RHEL 8.2 announcement, you'll see a lot of brand new security services that have been added to our Insights offering. Insights is a part of your Red Hat subscription, right? It's included as part of your RHEL subscription. There's no extra cost. And Insights allows you a web-based software as a service solution for scanning and remediating your systems, both for CVE vulnerability issues as well as compliance issues. You can actually scan your systems and bring all of them into PCI DSS compliance if that's what you would like to do. So again, we give all of you have access to our OpenSCAP tool, our Insights, and then Satellite's a separate purchase product to allow you to do kind of broad installation and configuration mitigation management on site. I wanted to make sure to leave you with a series of links that talk about our Product Security Center. So you can see some of them here. We have a CVE database. I saw some screenshots from that. We have OVUL and CVRF data feeds, which allow you to consume programmatically our feed of known CVEs, as well as our CVSS score and our Red Hat Security Advisory, RHSA, that addresses or remediates those particular CVEs. That's what you see there with your RHSA link. And then finally, there are actually a set of really neat security labs, both learning opportunities as well as scripts that allow you to identify potential issues on your system. Now, I mentioned earlier something about scanning vendors. How did I miss the slide? Hold on, I want to make sure I got it. Oh, okay, never mind. I seem to be missing a slide, but let me before I close, I want to highlight something. We do actually have a whole series of partners that we are working with, and those partners, including people like Qualys, Synops, Tenable, and others, we are working with them so that they understand how to consume the Red Hat OVUL data feed and understand where we give them our CVSS score and why our CVSS score is different from NVD. Like I said, separately, we're working with NVD to try and bring their scores into align with our understanding of the vulnerability, as well as if we have to disagree about a score, at least be able to list what the Red Hat score is on the NVD site. So again, we're working with these third-party vendors and scanning assessment tools to ensure that they have the ability to consume our data feeds. If you have your favorite scanning vendor of choice and you're finding perhaps false negatives, dare I say even false positives, let us know, work with us. We can work with you and your vendor to try to bring them into consuming our OVAL data feed. And what we find typically is that once Red Hat engages with a third-party vendor and they understand what we make available, they're very eager to work with us and give you the best experience possible, right? Okay, so in conclusion, we talked about generally what CVEs are. We talked about risk management and how a patch is created, including our supply chain. We talked about why scores may differ between the National Vulnerability Database and the Red Hat CVSS scores. Talked about how Red Hat addresses critical and important CVEs, and that we have a moderate and low policy that's focused around addressing those in the next minor releases of products where possible. And finally, we talked about the Product Security Center and give you access to SecAlert at redhat.com. And that brings me actually to the end of the deck. So at this point, Daniel, I think we are open for Q&A, and I see that we have several questions that have been queued up.
Yep. So let's start with the first question we have. Here it is. I'm using Red Hat UBI image to build containers. How do I know if they are updated with the latest CVE patches?
That's a good question. So the UBI is the Universal Base Image, and it represents our container technology. On a standard process, the UBIs are actually respun every 6 weeks, and they actually appear on our container catalog, which is a freely available catalog, with what we call a freshness rating. So you can actually look at our container catalog, see when the last time was that container image was updated, and when you drill down into it, you'll find if it has a graded score of A, B, C, D, E, and F. Obviously, an A indicates that this image has all of the known CVE patches available to it. Those are already integrated into the image. You drill down into it a little bit more, you can actually find the specific list of Red Hat bug advisories and Red Hat security advisories that have been applied to that particular CVE image. So in a nutshell, it's all available on our container catalog, which is freely available on our customer access portal.
Excellent. Okay, next question. Okay, this is something that you touched on. The Red Hat versioning when a patch is released almost never matched the upstream. When we scan, since Red Hat version does not match what the scan is looking for, it's marked as vulnerable. Mm-hmm. Then we have to go to Red Hat support or simply supply release notes to prove we are not in fact vulnerable. Right. Number of hours wasted is high. Will we ever see scanner vendors and Red Hat work together so package versions are better understood and not marked as vulnerable?
Yeah, that's an excellent question. As a matter of fact, I actually have almost weekly meetings with various scanning vendors to address exactly this issue. What we have seen is exactly the problem. What you have there is a scanning vendor that is going, quite frankly, a very simplistic worldview, which is, so it's all based on package versions, and they make no accommodations for possible backporting of security issues. Again, my experience has been when we pull in these professional scanning companies and we have a conversation around the fact that we actually make a consumable, freely available web API, not only a web interface, but an actual API that you can query over the web that contains a list of all of the CVEs by CVE number and the individual package and package versions shipped by Red Hat that contain a fix for that particular CVE, then all the vendor has to do is actually commit to consuming that OVAL data feed. We're certainly not going to be able to change our package versions to match upstream because that's not what we do. We bring backports. I found generally we can get very good traction with the vendors once we actually identify them and talk to them in person. What I will offer my personal perspective on is that for every N customers, there's N plus 200 security scanning partners out there, or partner vendors, if you will, of various different solutions. We don't know them all. I was quite surprised to learn of one the other day that is being used by a very large customer that I had never heard of before. So if you have an issue, I would encourage you to file a ticket, have that conversation with Red Hat. We are happy to engage with you and your scanning vendor. We have a team basically dedicated to trying to help our scanning vendors understand what Red Hat's doing. So happy to engage with you on that.
Excellent. The next question. Our security team advises to disable TLS 1.0 and 1.1 on Red Hat due to the vulnerabilities reported on many Red Hat servers. What is the best approach to resolve these vulnerabilities, knowing we have critical servers such as IPA, WebLogic, oops, I just lost, here it is, WebLogic and Web Apps?
Yep, pardon me, so that's a good one. So TLS 1.0 and 1.1 are definitely insecure at this point, and we definitely encourage you to disable them by default. In fact, in Red Hat Enterprise Linux 8, they are disabled by default. You have to take an explicit action in RHEL 8 in order to enable older TLS 1.0 and 1.1 functionality. In RHEL 7, our default is TLS 1.2, and we do provide you the ability to go through and disable on an individual crypto library basis the older implementations of TLS, but it's not as extensive of a capability as what we have in RHEL 8. So for the case of TLS 1.0 and 1.1, we do have some knowledge-based articles that explain a little bit more about how to do configuration of the cryptographic libraries. In this case, I suspect you're referring to RHEL 6 and RHEL 7, but I will also offer a bit of a note of caution. What I've seen over time is that individual applications, and I'm not going to pick on any of the ones that you mentioned, individual applications can often include their own cryptographic libraries. Now, those cryptographic libraries then run independent of any setting that you may have in RHEL itself. And it's up to then you to work with that OS vendor, or sorry, that application vendor to learn how to disable older protocols for a given application. So this is typically applications that are designed to work on multiple Linux platforms. They, for example, include their own implementation of OpenSSL. If they're using the system-wide OpenSSL or NSS or GNU TLS or something like that, we do provide instructions on the customer access portal about how to disable that. And I will also caution older versions of libraries like OpenSSL can make it kind of difficult to disable old TLS versions. So my advice, try to move to later versions of the operating system if you can. And if you cannot, follow what recommendations we've made available on our customer access portal about how to disable those protocols. And then third piece of advice, ensure that the application that you're running is actually using the cryptographic libraries that are provided by RHEL and not actually silently using their own cryptographic libraries, at which point you have to work directly with that application vendor to disable those.
Excellent. Next question. Is it an acceptable process to only apply security patches to reduce impact on applications?
Yeah, great question. Not only is it an acceptable policy, in the Yum update tool included with Red Hat Enterprise Linux, you can actually turn on a mode that allows you to only install security updates. So we actually have that. For example, we have certain common criteria deployed systems where the recommendation is if you want to, maybe all you want to do is install security updates. So here's the easy command line way to turn on Yum to where the only patches that it installs are those that are marked as RHSAs, Red Hat Security Advisories. The opposite of this would be when you install patches, you're installing both bug fixes as well as security vulnerabilities. So the answer is yes, it is a valid mode of management to only install security advisories, and that is absolutely something supported by default in Yum. And if you want more information on that, either I can provide it to you, or you can find it actually in our product documentation set.
Excellent. Next question. Why security tools like Nessus, Tenable may have different score than Red Hat?
All right, that's good. This relates back to the concept that Nessus and Tenable, in the past at least, have consumed and only made available a single score, and that score is the one from the National Vulnerability Database. Now, I've had some customers say, well, that we can't trust Red Hat, right? You are making the OS, you're making your judgment on your vulnerability score. Therefore, we have to go to the National Vulnerability Database. And as I hopefully relayed to you here, the National Vulnerability Database only provides one score. That score is not opinionated based on the actual implementation of that technology in a vendor's product. Therefore, we may have a different score based on how that technology was built and our backports that we've done to RHEL. Over time, we hope to influence that. I have seen MVD actively change their one score to match what Red Hat suggests that it is based on our technical exchange of information with them. And MVD is getting better about listing vendor-supplied scores as well. We're not the only vendor that has this issue. All the major IT vendors keep track of CVSS scores a little bit differently than MVD does. So we all would like to see MVD be more clear about scores, why they scored it the way they did, that kind of thing. So the answer is, because MVD only has one, they typically take the upstream score, unless we've been able to influence them, or unless they will be willing to list an individual vendor score. That should change over time.
Okay, excellent. Next question is more about CoreOS, but I'm going to read it anyway. So we are using CoreOS to build the OpenShift cluster. How do we know the CoreOS security is, how do we know if it's hardened?
Okay, good question. So CoreOS is Red Hat Enterprise Linux CoreOS. It is an opinionated configuration of Red Hat Enterprise Linux. It uses the same kernel as Red Hat Enterprise Linux. It actually uses the same cryptographic modules. Everything that shipped in RHEL that also ships in RHEL CoreOS is the same versions. What happens though is RHEL CoreOS is respun and regenerated frequently, and when it does that, we catch it up with the latest and greatest CVE issues. We are actively working on a compliance operator. Oh, I should pause. RHEL CoreOS is only available as a part of our OpenShift 4 product set. It's not an independently available operating system. You don't run general purpose operating system loads on it. It is considered to be a semi-immutable operating system in that things like the user mount point is read-only, right? You do not log in to RHEL CoreOS. You don't SSH into the box and go do whatever you want to. So it is, again, an opinionated, immutable operating system designed to run the control plane and worker nodes of OpenShift 4. So all that being said, one of the items that we're actively working on, and you will find even more information about it in the most recent sets of OpenShift 4 product announcements, is what we call a compliance operator that will allow us to do scanning and remediation of the cluster itself, including RHEL CoreOS. Quite frankly, with RHEL CoreOS, it updates very frequently, and it updates to include the latest critical and important CVEs as they snapshot into Red Hat Enterprise Linux itself. So the short answer to your question, if there is a known problem with CoreOS, and CoreOS is affected by a known CVE, that will appear in our database. That will appear in our OVAL data feed. You can always check our CVE list, and that will tell you what version of OpenShift and hence what version of RHEL CoreOS is potentially affected by a known CVE. So to fix the problem, you update to the latest version of RHEL CoreOS. It's a constantly moving forward it's a constantly moving forward operating system. And again, it's tied with OpenShift and fully identified in our CVE database. So if you look for a given CVE and it doesn't list RHEL CoreOS as being affected, it's not affected. But if RHEL 8 is potentially affected by it, then RHEL CoreOS could be affected by it, and you would see that listed in the database, in our CVE database.
Excellent. Next question. What is Red Hat security strategy for various hardware drivers?
Okay, right. So for hardware drivers, in this case, we're talking about software drivers that enable net new hardware devices. Our policy is exactly the same as everything else we just described. And what I mean by that is Red Hat only ships in Red Hat Enterprise Linux or in any of our products. We only ship what's in the open source, right? We do not ship, as a part of RHEL, we do not ship closed source binary drivers, right? We can make those available. We will reference those from third parties, but in general, we only ship what's in the open source. So I return back to the previous conversation. If there's a known vulnerability, and for example, let's say it's a video graphics driver, that video graphics manufacturer or a network card manufacturer will work in the upstream to make the patch available in the upstream. We then bring it through Fedora and into Red Hat Enterprise Linux, just like we would any other CVE, and we treat it the same, critical, important, moderate, and low, and we address it exactly the same. So there's no differentiation at all. The only differentiation is if it's a hardware driver that we don't actually ship as a part of Red Hat Enterprise Linux, then we're not going to ship a fix for it because we didn't ship it, right? It's up to that individual graphics or network card driver to ship that updated version of the closed source binary driver to you. But if it's shipped in RHEL, it's exactly the same response for CVEs on hardware drivers as it is for any other software vulnerability.
Excellent. So we're almost out of time. So here are the last two questions. First one is there any reward for CVE identification? And also the last question is, will the slides be available after this webcast?
Cool. Daniel, I'll let you handle the slide availability question here in just a minute. We do not offer a reward for CVE identification. That's a certain type of model that we just do not currently do today. Remember, everything we do is in the open source, so we want to make sure that everyone benefits. Quite frankly, we like to rely on the good nature of people to benefit the entire world if there's a known CVE. If you think you've discovered a CVE, then of course, absolutely let us know about it. Because if it affects us, it may likely affect other Linux and open source vendors as well. So we want everyone to benefit from that. So short answer is no. Long answer is we love to participate in the community. We like for everyone to participate in that. Okay, and then Daniel, do you want to talk about slide availability?
Yes, sure. This is something we can make available to the presenters after this presentation. And the other thing is this webcast is going to be available in replay for about a year after its date of after today. So it's not an issue. And we're going to follow up with anyone who has any questions. So I think we covered everything.
Awesome. Well, I, for one, definitely want to thank everyone for attending today. Thank you so much. I hope you learned something from this. It was my pleasure to present this to you, and I look forward to seeing you at Virtual Summit 2020 from Red Hat next week.
Thank you very much. Have a good day, everyone.